So 6 coins. Now these are kind of weird, 3-sided. And the simple reason for it, well, it's slightly humorous, but if I do a 2-sided coin, you can't, and I write the probability up, the probability of getting a heads and a tails are of course exactly the same, right? And so in the example it starts to blur which one are we talking about. So in this case, by making it a 3-sided coin, it'll be easier to see, to keep track of the probabilities, okay? So head, tails, and toes, and what we want to know is the probability of getting tails, okay? And we want at least 4 tails, okay? Now I'm going to start off by showing you a bigger, longer way to do it, and the reason is because it will make more sense. The good news is once you see how this is organized, you don't have to do it this way, okay? So it's almost better maybe just to watch the first part. So if I'm going to shake 6 coins, when I get to the first coin, what's the probability of it being a tail? 3-sided coin. 1 out of 3. Yes. Just like that. And see. In fact, let's start off with, we'll do exactly. And then we'll come back to the at least part, okay? Then we'll change that. So this would be my tail. What's the probability of getting another tail? 1/3 again. So we got tail, tail, tail. 1/3, 1/3. But I have 6 coins. And if I want exactly 4 tails, this has to be not a tail. It could be heads or toes, right? But it doesn't matter. It's simply not a tail. And what's the probability of that? Yeah, 2 out of 3. And 2 out of 3. And there we go. So there's our 6 coins, right? Here's the probability of getting my tail like I want, for my 4 tails. And then these are not tails. Good so far? Now, you remember we talked about, we had the word Mississippi. This obviously, we could switch the orders of these. And so this is more likely than what I'm showing here, right? The probability we have now is that you get exactly 4 tails first, and then you get 2 that are not tails next. And that doesn't really need to be the case. So how can I switch these around? How many ways could I switch them around? And again, just like we did the word Mississippi.
It was the 6 to 4, right? No, something like that.
Oh, no. Now, yes, but yes. Okay, so one way we can think about it is, if we're doing the Mississippi thing, you have 6 factorial ways we could switch it around, right? And then what do you do with the letters that repeat? Divide them out, right? So I would divide out 4 factorial and 2 factorial, right? So that's how we handled the Mississippi problem, right? The total number of letters, and then you divide out the repeats. Okay? So in fact, that would allow us then to take into account all the different orders that could occur. Okay? So this would be, if we wanted to actually put it in your calculator, that would be one of the answers. That would be for the exactly. Okay? Now, that's something that actually, go ahead and do this in your calculator. What do you get? And I loan you mine, but I didn't bring it. In fact, I even forgot my phone at home today. So 15. Nods on that? Okay. Now, but you are also saying... No, it's worth thinking. Go ahead.
Never mind.
I think what you started to say was 6, choose 4, didn't you?
Yeah, I was thinking of the combination.
Yes. And go ahead and do that on your calculator. What do you get? You do. That's right. You also get 15. Right? Okay. In fact, while you're there, try one more thing. 6, choose 2.
$15.
15. Okay, and it's so by taking a permutation and by dividing out the repeats, it actually is kind of the same as doing a combination. Okay? So as you're doing the homework, either approach works. To me, this is slightly more intuitive, but maybe this is a hair quicker. You'll notice in the book, they will tend to do this. Okay? So instead of having this thing out front, they're going to go 6, choose 4. Now, when I do this all out, what told me I had to pick a 4 versus a 2? I mean, I've got 4 here and 2 here, right? And so, in fact, the answer will be that it doesn't matter. You'll get the same results both ways. And there's a bigger pattern to that. I mentioned the word Pascal's triangle. When I get to that, suddenly the reason these are the same will make sense to you, okay? You don't need to know it to get the answer, but it certainly is easier to get there more often when you know why, okay? So here's 3 different ways we can get that number in front, okay? Now, one more thing that we can do to improve on this. So we'll write this up here. 6, choose 4 also works. You can imagine if we had a dozen coins, this starts to get obnoxious, right? Okay. So a nicer way to handle this would be to say 1/3 raised to the power of what? And 2/3 raised to the power of 2. So then again, coming back here, you'll notice it doesn't matter which one we use here. There starts to be some nice patterns, right? See, those 2 numbers are going to be the same as those 2 numbers. Okay? And of course, these 2 will add up to be that one. Always will work that way, okay? And in fact, if we just go backwards to that formula now, so you can see up here we have NCR, so that would be our 6, choose 4, right? And then here's our first probability, just raised to the power of, this is going to be the same as that, right? Okay. And then this one here, another way to think about this is 1 minus the 1/3. Or of course gives you the 2/3, right? Okay. And then if we took our R4, let's see, did I get that backwards? Type on that. It should be n minus 4. 6 minus 4. There we go. I need to go fix that. Got the 2 backwards. Okay. And of course that gives us the 2. So whether you even need the formula at this point, I don't know. I mean, because this makes sense to you, doesn't it? And from there you'd immediately say, well, yeah, that makes sense. And when you're doing your homework, a lot of times you'll probably just want to start right there. Okay? So I don't know that you need the formula now that you see that. Okay? So whether you choose to do permutations like that or a combination like that, that's your choice. Okay, whatever you like the most, whatever you can remember the best. I think they both will work, and the book tends to use this in their examples. All right. So everyone fine with that one? And you're comfortable? You could put that. Should we get this answer here? Would that be helpful to put that in the calculator or not necessarily? No? Okay. Okay, now if we change the problem, the original problem said at least 4 tails, right? So now we have exactly 4. So then we would need to get exactly 5 and exactly 6, right? So how would I change this right here? Well, excuse me, what would I...
1/3 power.
Yep.
And then 2/3.
To the power of 1? Yep.
And
it's worth writing down though, actually. Yeah.
Okay, and then 5, 1/3 power of 6.
Mm-hmm. Yep. And then this part here, we also need to include then here and here as well. Okay? And so again, we could either do it this way. Well, let me be just consistent here. So this would be 6 factorial over 5 factorial, 1 factorial. Oh, 1 factorial. There we go. And then this would be 6 factorial over 6 factorial, 0 factorial, right? And again, when you look at it, 6 and 0 give you 6. Those two numbers will add up to be that, right? These add up to be that. These add up to be that. So there's all kinds of nice little patterns here you can use to check yourself. And again, if you choose not to do the permutation approach, you can go, 6, choose 4. Here you can go 6, choose 5, and 6, choose 6. Okay? All right, is everyone good? So let's see. Something that might save you a little bit of time. So if you don't get this part, don't worry about it. But it might make it easier in your calculator. For example, when you look at the numerator here, what's the numerator without even using a calculator? So 2 to the 0 is, it goes away. 1 to the 6 goes away, right? So in fact, this becomes then 1 over 3 to the 6th, right? And if you just look at this, what's this one going to be? Can you see it? Just the numerator. It's just 2, right? 5 to the 1st, just a 1. So we get a 2. And our denominator becomes 3 to the, and we've got 1 there. So 6 again, right? So what happens then is you find here, we've got 3 to the 4th, 3 to the 2nd, 3 to the 6th again, right? Okay, and here, of course, you actually have to do 2 to the 4th, so we get a 4. So I think you'll find when you start looking at these fractions a little closer, you can actually do them. I mean, don't be afraid to use your calculator, but it's sometimes you can get there without plugging the whole thing in. Okay, and if you prefer to plug the whole thing in, do that, okay? But I just wanted to show you that actually it starts to clean up kind of nice. And it'll tend to do that. Okay, so let's try another one here. And this time we'll use some dice. Okay, so probability of getting no more than 2 5s with 6 dice. So what we're saying is we want to know the probability, I could write it out that way, of getting 0 5s, right? Probability of getting 1 5, and the probability of getting 2 5s, right? So do we agree that's the question? Okay. And so let's start off by let's find the probability of getting 0 5s. Okay. And thinking about the way we solved the last problem, what's the probability of getting the first 5? Well, okay. Okay, let's do it backwards then. Let's start with this one here. What's the probability of getting 1 5? And then 1 out of 6. And since we want 2 of them, squared, right? And then what else do we want over here? Probability of getting something that's not a 5. 5 out of 6. So, but we've got 2 we want to be a 5, and how many then are not going to be 5s?
Well, it doesn't
Let's see.
say how many times.
No more than 2 5s from, we're 6 dice.
Okay.
Yeah. 4, right? And I'm going to leave some space there for a moment. So then this would be the probability of getting exactly 1 5. Yep. Yep. So 5 die that are not 5s and one that is. Okay. And then, what's this one going to be?
1, 6 times 0. And then 5, 6 times.
Yep. And then again, we need to take into consideration the order. Do you prefer to do the permutation or the combination format?
Combination.
Combination? Okay. So what would this one be here? Six choose 0, yeah. And then this would be 6 choose 1, and 6 choose 2. There we go. Feels okay, doesn't it? Okay. So now let's add one more twist to this. And don't worry, it's not bad.
Are the 6 choose 0, is that part of and then you also do the fraction?
The other way you could do this would be 6 factorial over 0 factorial 6 factorial. Yes. Right. These are the only two parts yeah, but this is all multiplied together, right?
Okay.
So you could do this part, the first part, either way, but then it's going to be times and then times the second fraction. It's pretty cumbersome to put the whole thing in your calculator once. It'll probably be a little easier to do it by chunks, okay? But there's an easier way, actually, okay? I don't want you to forget this. In fact, I would recommend in the homework, when the problems are a little simpler, in other words, when it's like 2 or 3 things, I would recommend doing it this way. And as soon as you run into a problem where you have like 15 or 20 things, you should probably do it the other way I'm about to show you, okay? Because I'd like you to be good at both, but use your calculator, the thing I'm going to show you in the calculator for the long ones, okay? So let me pop open a calculator, and if you want to get yours out, and I will show you. Whoops, not that one. So do you remember how to find when we did normal CDF? Do you remember where that was at? It's been a little while. Normal, and we had CDF, and actually we had normal PDF. Yep, you go second, but actually it says vars or distribution. Correct? So we want to go there. But instead of using the normal, here, let me jump over there myself. So I go second, vars, and instead of going, you can see right away in your calculator, you get the normal CDF and normal PDF, right? We want to go down, or actually the easiest way is to go up, and it takes you all the way down, okay? And then you go up a little bit, and we have now what we call the binomial PDF and the binomial CDF. Okay. If we're trying to get exactly, if we have a problem where we want to know, exactly 5 or exactly 6, we will use this one. If we're trying to use a situation where we have no less than or no more than or something like that, or at least, you're going to want to use this one. So anytime you see the problem, say at least, no less than, and all those different variations. And the difference is, so it's kind of the similar shape as the normal curve. Of course, when I draw it by hand, you can't tell the difference between a binomial curve and a normal curve. All right? So, but this one is going to tell you exactly 1 point. Okay? Whereas this one it'll tell you everything to the left. Remember we had that thing going on before, right? So when you do the CDF, this stands for cumulative. And so it's saying all of this stuff here added together. Not just the one value, but everything. That's what the C stands for. The only thing you'll have to keep in mind is this works great for no less, at least. No? Actually, no, it would work great for no more than. Because then we're saying this and everything less than that, right? Okay. So if you want to have it an at least or no more than, in other words, if you are interested in stuff over on this side, then we're going to have to do the 1 minus our answer. Okay? So it's always, when you're using the CDF, it'll always tell you what's to the left of the point. Okay? So again, if we're interested in this side of it, when we get our answer, you need to go 1 minus that. Okay? So now let's work through a few of these. In fact, let's go back right up here to where we had the three-sided coin. Okay, so let's try to do that, and let's do the exactly 4 first. Okay. So we're going to do PDF because we want exactly one value. So, and some of you, your calculator actually will prompt you for the values. So the first value would be how many coins. So in this case we have 6 coins, comma, and then the probability, of course, was 1 out of 3, right, of getting the tails. So you could type in a decimal, but you can also just type in a fraction, which is what we had, right, 1/3, comma, and then I want, if I'm after exactly 4, I'll put a 4 in, and I'll close my parentheses like that. So we're doing PDF. So for we had 6 coins with a 1/3 chance, and we wanted to know for exactly 4 coins, right? So you should be able to hit enter right there, and there's the probability. So it came up to be 0.08. Okay, is everyone comfortable with that? Now let's come back though and it said at least 4 will be tails, right? So actually the one line is pretty good. So we're saying we wanted to know 4 and more, right, for this problem? So there's a little bit of a trick to this because we can only find what's to the left, right? So let me... So if I want everything that's down here, what you actually do is we're going to put in, it's kind of like the same line. I'm going to put in a 3 and less because I don't want to include the 4, right? So what I'm trying to do is find everything below the 4. And with dice, we don't have like half of a roll, or coins. We don't have half. You either have 4 coins or you have 3 coins. You don't have 3.5 coins. Okay. So I'm going to do this binomial CDF this time. So I go second. Okay. So there's the binomial CDF. We still have 6 coins. Still have a 1/3 chance of getting the tail. But now I'm going to put a 3 in to get everything from the 3 to the left, right? I close my parenthesis. There we go. Okay, so now I went of 6, comma 1/3, comma 3, and I ended up with 0.899. So now to get what I really want over here, I'm going to go 1 minus 0.899. Okay, So then that's going to be 0.11 roughly. Depends on how I round that, huh? Or something like that. Is everyone doing okay with the calculator? So then let's try a couple of problems in your book using the same thing. So problem 36, 38, 40. If we could do a couple of these, I think it'll be helpful for you. So what's 36 say? So this is in... Yes, 11.4 for you. Mm-hmm.
36, okay, so a recent study found that 85% of breast cancer cases are detectable by mammogram. Suppose a random sample of 15 women with breast cancer are given mammograms. Find the probability of each of the following results. Assume that the case is independent. So 36 is none of these cases are detectable.
Okay. All right. So first thing we know is we have 0.15 and 0.85, right? This is the probability of being detected, probability of not being detected, right? And these probabilities, again, will always have to be equal to 1. Now we're trying to find not detectable, and now it said for all 15 women?
Yeah, so it's none of these cases are detectable.
Right. Mm-hmm. So none are detectable, so it means that, so this would be, we could say like 15 are not detectable. We could do something like that, right? Good. And then what we put in front? So what is it? So 15 choose. So in this case, we want to choose that all. Oh, see, none are detectable. I got to care. In other words, all of these are not detectable. The way I have it written here, right? So all the cases are not detectable. Okay, so that would be one way of doing it. No, not a good idea. Not now. So now if we try this in the calculator, so we'd have binomial. So we have 15, and we're after not detectable. Oops, yeah, I skipped those words, didn't I?
Would it be PDF? Would it finally like that exactly?
That it's exactly, yes. And we're saying it's actually, we want it not detectable for all of them. Okay? So you should be able to plug this in, and you should be able to do the same with that, and you should be able to get the same results. Right? So let's go try. Do you want to do the button pushing, or should we just go to the next problem?
Wait, the 15 choose 15, and then the binomial PDF. Those are going to use the same answer.
They should. You got different answers?
Yeah, so for the binomial PDF, I did 15 with a small amount, 0.15, 15, and the answer was 4.3789 to the negative 13.
Okay. Yes.
I got the same answer, because you have to multiply the 15 to 15 by
Times
and then you multiply it.
that.
Right.
Yeah.
Okay.
And of course now this one's going to become a 1.
Right.
But so it really becomes 0.15 raised to the power of 15. Yeah. So maybe it was worth everyone putting the numbers in then. Make sure we get that. Let's see, 38. What's 38 say?
38 is based on the same information, but instead it's more than half of these cases are detectable.
Okay. So if we're trying to do it this approach with more than half, we would start off, we have 15. So more than half, if it were half is 7.5, which of course doesn't make sense. So we could use 8 or more. Do you agree with that? Is the way we could read that. So 15, choose 8. And we have 0.15, 8. Oh, wait, detectable or not?
Are detectable.
Are detectable. Okay, so I need to change that a bit. I'm going to put my 8 over here on the detectable, which means I have 7 there. Is everyone okay why I put the 8 here now? Mm-hmm. Not sure? Okay, so this problem said, up here we are trying to find not detectable. That's why we focused on this number. This is the not detectable number. This problem is wanting us to calculate for being detectable, which is that. So that's why I put the 8 there, which then the rest of it would go here. Okay. Now, pretty quick you'll see this is obnoxious because I have to do choose 9. Then I have to do 15, choose 10. And I've got to go clear on up here to 15, right? Yeah. So that's a pain. So we'll get 9 and 6 and so when you run into these, try not to do those, okay? This is really the time you want to switch to this approach. All right. Now, we're not after a single point. We're trying to get from this up, right? But the calculator is going to calculate it from here down, right? So what we want to do is use the 7 and everything that's less than 7. When we get this answer, we're going to do our 1 minus that to get over here, right? Because what we want to know is everything over here. Okay? So I think we can get this answer. So then this will be binomial CDF. So like up here we have 15, comma. This time this was for not detectable. That was the question. This question is for detectable, so we'll put in 0.85. Now again, we're not going to use the 8 that shows up in the problem. We're going to use the 7. Okay? Is everyone okay with why we're using 7, not 8? All right? And if you do that, what do we get?
6.096 times 10 to the negative 4.
To the negative 4, you said?
Yes.
Okay. And now to get what we really want, in blue here, we're going to go 1 minus this answer. All right. So as you're going through the homework, definitely be trying to do some of them this way. And the first ones will tend to be smaller groups, so I would do it then. And then as you go along, you really want to switch to doing it this way because it just gets obnoxious. And if you have time, do problems both ways. Sometimes it's really nice to see that 2 very different approaches gives you the same answer. Okay? And that's almost like worth extra credit on the test if you get a little extra time to do that. Okay, any questions then? So give it a shot, and again, don't let yourself get stuck in a rut. Just come with really good questions on Wednesday, okay? And then Wednesday we just have one last little piece. So have a good day.